I'm here this time not presenting on behalf of ATEM and Focus VR, but on behalf of a consortium which carried out a project which was called AR Launch, a Eurostar, Eureka Eurostar project. And basically, we left the topic before. We had immersive video, spatial video, 180 degrees. Here we talk about extended reality and low latency. So I'm going to explain a bit what it's all about. So here's the agenda. I think I skipped very quickly, so we have more time for the more interesting things. So the context is that we have an XR market which has 30% revenue growth per year. So that's quite big, quite important, and that's why also there's so many people getting active in this field, by the way. But AR and multi-view is still early days, and I think we have an expert also who is moderating the session on this topic. And we want to validate complete end-to-end workflows. There are some tuning to optimization for low latency performance and interoperability issues. We have currently, at least when we started the project, there was no end-to-end workflow permitting things like real-time data being displayed together with the video in an end-to-end chain, having multi-view, so several views that you can display in the same time all together, highlights detection, and timeline navigation back and forward. I mean, all these elements you can find isolated, but having this all together in one solution was the objective. And that's what I'm just explaining here, basically. And one of the targets was of course, to make it as commercially real as possible. So that means limiting the equipment on site, server on site and remote clients, combining real-time data with multi-view video, offer highlights for back and forward navigation, and having an overall latency below 2 seconds. And we'll see it's a bit challenging. So in terms of partners, there were 2 partners in France. So Immersive.io is a company startup specialized in UI. Maybe you have seen some of the applications, and ATEM. In Switzerland, there was NewLink, specialized in wireless technology for instance, for cameras. EPFL, so l'École Polytechnique de Lausanne, and the Haute École d'Ingénieurs et de Gestion de Canton de Vaud, so Hague VD. And in Portugal, there was Sixth Floor Solutions, which is a specialist company who is carrying out some highlights detection features. Maybe also you heard of them. So the challenges. I put 4 challenges together for you. One thing is getting the highlights in almost real time. So by detection of, the produced, some non-produced streams or multiple streams combined, that's really challenging, at least still challenging also with the captures which are not optimal for detecting. So one of the things which are challenging. The other thing is the contribution challenging. So challenges, 5G contribution, so that's at least what is the plan, what was the plan. And for that, you have all the cameras which need to be perfectly synchronized. You need to also to have very good latency, very low latency. And then on the distribution side, so we're proud to be the biggest contributor of latency, obviously. That's clear. So the idea is here to cut latency at every stage of media distribution. And then, of course, on the application side, you have the challenge that, well, the UI is not, there's a lot of experiment how you do. And of course, we wanted to serve several devices at the same time. So you'll see a couple of snapshots later on. So what we have as a solution, as you can see, it's outlined here. So on the left-hand side, you've got some cameras, several cameras, which are fed to a 5G private network. This goes down to an encoder. And this encoder delivers then the one part of the stream to one of the representation of the stream to Sixth Floor Solutions, which is a cloud service for detecting highlights. And the other part goes to the CDN server via CMAF. And this is then all streamed to devices at the households. And as you can see, the application metadata, the application of Immersive.io has also an application server which communicates with Sixth Floor for the detection of the highlights and gets also the real-time data back. So then at the end you can have such, as you can see, with a tabletop, for instance, some representation or several views also available. So I picked 5 of the things, well, I'd say key things that we developed. This is on the 5G contribution network. So it's a private network. It uses dedicated pseudo slices for video streams and very low latency parameters. And synchronization is done by a PTP-D, sorry. And as you could see, the difference between the different, so if you have master clock in the master and the client, it's below 2 milliseconds. And the I think the latency was below, so until it ends up in the SDI input of the encoder, I think 100 milliseconds, so something about that. So on the encoder side, what we did is we used, as you can see, as an input is HX-NDI to SDI, which has been used before the contribution. It was used as a format because we thought it would be more effective in terms of latency and what you have as budget. We use an ultra low latency mode in the encoder. Mode, so it gives about 1 second in terms of overall latency. And one part of the representation goes via SRT to the 6th floor solutions server, which is going to do the detection of the highlights. And then between the encoder and the origin, we use CTE, also to speed up basically the transfer between both. And then we had a lot of discussions and experimented about whether to put the origin on site or not. We finally decided it would be good to have it on site in order to also to be able to decrease basically also the latency for the on-site distribution. Then you've got several architectures. So what we use for the synchronization with the NTP, we use the NTP timestamp, so that come from the camera. We go via SDI, via private VANC message via SDI, and then we transport via, for the SRT, is transport stream. So for that we need a TEMI timeline descriptor, which uses the carries the NTP's timestamp, and in the ISO-BMFF, which comes to the player at the end, we use a PRFT box, so a producer or reference time box for in the ISO-BMFF. And then you have the correspondence between what's coming from the capture, which goes down to the highlights. So there is an API which goes between the highlights and the player, the application player, the application server, and then at the end you have this correspondence between where the highlights are, when was the time captured, and also the correspondence between the different streams. So in the highlights detection side, that's about what you can achieve with this. So you need several views. If it comes to soccer, for instance, we achieve 100%. So close to 100% success. When it comes to other things, so I don't know, penalties, things like that, sometimes it's less, it's 90%. So you get all this kind of APIs, so get events by game, get games, get live games, get events by player, team, league, or season. Obviously, this is combined with other data, where you can recognize and identify the player. Get highlights per game, so all these things are available. On the right-hand side, you've got 2 pictures, so one which is identifying basically the limits for the goal, and then here above you have tracking basically the different players. So as an example, the overall latency is about 2 to 3 seconds. So that means you don't get the live highlights exactly when they happen, but you get them with 2 to 3 seconds later. So here's an example of the applications which were developed. So it was developed for Android, iOS, MetaQuest, AR glasses. I said it uses real-time data to display graphically where the players are, for instance, or the ball are, and it combines this with statistics. And basically, the players does the synchronization using PRFT, which is used by extracting NTP timestamp at capture. So the player manages also the timelines where you can navigate back and forward, and also shows the highlights where they are available. Yeah, just as a summary, so we have a solution basically which is a hybrid solution, so not everything is the cloud, some things are on the prem, because of course, obviously, also to keep down the latency. It features wireless synchronized multi-feed via 5G. The overall end-to-end latency is about 2 seconds. I'm going to give some hints about that later on. And the synchronized display of multiple views with real-time play and ball data as graphics is possible, and highlights the navigation based on a raw video. So without all the overall layout is possible. That's something which is even more demanding. And we had some core components which were showcased at DAZN's XR app for the FIFA Club World Cup 2025. So in terms of synchronization and latency, this is still a balancing or optimization problem. So that means if you want to synchronize all the streams, then you have some buffering running back and forward, and that's where you lose a bit latency. That's still the issue, which is a fragile thing to achieve. So I just want to be very clear that this is a challenging one. And then, yeah, what we also think is when we started the project, there was no things about, for instance, MXL, which you get a session this afternoon. I think this will be the next session. That's something which we would have liked to explore, because this could bring a number of interesting things. We were a bit caught with the SRT here, which of course is not the most optimal way to connect to an external server. And then in terms of immersive video, so you heard the story with the immersive video a couple of minutes ago, and this was just exclusive 2D. So the idea is now probably to combine both, but the problem is here is that, well, you have to do the detection or projection, or you have to do the projection and do the cropping before you do the detection. Then you need to track right. I mean, I heard a nice presentation yesterday about the topic, so maybe that's food for thoughts. You have a complete delivery chain in MV-HEVC, so there the latency and the processing is a challenge. Obviously, the 2 seconds I was talking about, this is not what we reached today with MV-HEVC. There's still some work to be done. And then, of course, the wireless bandwidth for the immersive pack captures, I don't think it fits over SAF5G networks, at least as we configure it. So maybe that's also a key requirement for 6G, I don't know. And then the next thing is, of course, we have a solution working, but there's also the monetization aspect. So ads, product placement, integration, things like that. That's something which would be needed for have a commercial viability of AR, VR. Else you end up with subscriber-based, ticket-based, that's nice, but there's also a lot potential about product and advertising in the field of XR. And I think that's all. Thank you on behalf of the consortium.
Thank you. 5G is interesting. We've had lots of customers that said, yeah, I have great 5G bandwidth. I want to do my contribution of my 8K camera over 5G. And then they did a speed test and they measured downlink bandwidth, not uplink. Anyway.
We would have not succeeded if you were to...
No, it doesn't. Downlink and uplink are not the same thing. Any questions in the room? Yes, there is a question. Yes. Doing my morning run.
I wonder, could you share a little bit of what you think some of the ad insertion challenges are going to be that you sensibly left to the next phase?
Well, the project's ended, so basically, but
that's a cop out.
I'll go out and the if I can go back on these ones, yeah. So again, the challenges on the detection, on the projection, I think again the latency is. To get all these things to be done in latency is going to be a really tough thing.
But why? I mean, I've done dozens of VR projects, and 2 seconds was never the target. Never. There's always 10, 20, 40. It was good enough. Why do you choose 2 seconds? Why do you make it so difficult for yourself?
Well, it's in the case if you want to do some things like bettings and things like that, then you need to really have a very low latency. Yes. So if you have more time, then it's also easier. So that's I think latency is one of the things. The projection, the detection, the projection, I think that's something which might be feasible, but it's also going to require some effort. But we heard there were nice things yesterday. I think in the session I had the honor to share. And the MVGVC latency and processing challenge, I think for MVGVC we can get it down to 5 seconds for the encoding. So that's about that. But then you have to add all the bits before and by head, so that you're not going to reach at least the 2 seconds. That's going to not to be possible. And then the bigger thing is, how do you capture that and transmit this? Is probably going to be wired and not wireless.
Any other questions? I think I saw in your delivery that you deliver the data separately from the video. Have you
Yes. Yes.
have you considered packaging the data with the video and doing the lining it up at the transcoding?
We haven't considered that because for the simple reason that our colleagues from Immersive.io, they've got directly the data from the sports
Sure.
venue. So that's not our business.
Okay, separation of
But
concerns.
technically, maybe it's good. It's a good thing.
Yeah. Okay, in that case, thank you very much, Jan.